A human thought is a web of context, memory, and subtle intent. Interacting with a database requires stripping that context away, collapsing a complex information need into a handful of isolated words. It is a highly lossy translation. Standard data retrieval treats those words as a mechanical command, returning documents based on exact string matches. Information retrieval requires a more sophisticated approach, ranking documents by inferring their semantic relevance to the user's actual goal. Bridging vague human input and precise algorithmic output requires a specific architecture, dividing the problem into two disciplines. The upper branch defines the query language, rules for syntax and logic. The lower branch analyzes query properties, modeling statistical search behavior. Efficient search depends on this dual-pronged approach. The system must evaluate the mathematical structure of the request, while simultaneously accounting for the unpredictable nature of the user who typed it. The foundation of text parsing begins with single-word keyword matching. The system evaluates document relevance using term frequency, the count of a word in a specific text, and inverse document frequency, which measures how rare that word is across the entire collection. Systems use Boolean operators to build syntax trees. Here, an AND root retrieves documents containing translation, along with a second variable. This branches to an OR node. A match must contain translation, plus either syntax or syntactic. The engine processes this logic bottom-up. Transforming a flat string of text into a multi-tier logical tree allows the engine to enforce hierarchical constraints across billions of records. Syntax solves the mechanical parsing, but decoding human semantics requires empirical data. For this, retrieval systems rely on query logs, databases recording the exact text, timestamp, and IP address of every search. Plotting the frequency of words used in search queries against those same words published on the web reveals a distinct statistical signature. Both follow a Zipf-ian distribution, but what text has an alpha parameter around 2, while search queries hover between 0.6 and 1.4. These logs also track long-term shifts in societal intent. Historical data shows that between 1997 and 2001, commerce-related queries rose from 13% to nearly 25% of all traffic, signaling the transition of the web into a primary marketplace. Even with this massive modeling of intent, roughly 16% of all recorded searches remain inherently ambiguous. The terms lack enough context for the engine to determine a single, distinct goal. The measurable gap between what users search for and what publishers write ensures a baseline margin of error in all retrievals. When an ambiguous query enters the pipeline, the system must predict its own likelihood of failure. This is the engineering problem of query difficulty, determining when a search will return poor results. The simplified clarity score is a pre-retrieval mechanism. It calculates difficulty using collection-wide statistics before execution, comparing the maximum likelihood estimator of a term appearing within the specific query against its total frequency across the entire collection. Post-retrieval mechanisms like the clarity score execute the query first. They analyze the language models of the top results. If those results form a cohesive topical cluster distinct from the broader collection, the query is deemed successful. These approaches present a strict engineering trade-off. Pre-retrieval is computationally fast, but relies on sparse data. Post-retrieval is highly accurate, but requires evaluating a ranked list. Determining exactly when to calculate system confidence, balancing speed against accuracy, is a defining architectural challenge of modern information retrieval. A modern query navigates a gauntlet of logic and probability. The request is parsed into syntax trees, cross-referenced against Zipf-ian distributions to map intent, and continuously scored for difficulty to adjust the system's search strategy. This pipeline facilitates an active algorithmic dialogue, with the engine weighing statistical evidence in real time to resolve the inherent ambiguity of language. The ultimate utility of a search engine rests on its ability to mathematically calculate its own level of confidence in understanding human intent.